Welcome to Generics in Java. In this unit, we are going to cover an introduction, trying to understand what we mean by generics. And we are also going to cover how we implement generic methods. And what is a bounded type parameter? Is it possible to overload generic methods? And if so, how do we do it? The issue to do with the type erasure, as we're going to see the process of creating generic methods. We would want to understand how the types in generic methods or generic classes are actually handled at a compilation level. We are also going to look at how we can create generic interfaces and generic classes. Our discussion also look at the issues to do with inheritors. Can we inherit from a generic class, or can we have a subclass which is generic from maybe a generic class, or issues related to that? Lastly, we'll be looking at the row types. Let's begin. We have been coming up with functions before as maybe one way of achieving a polymorphism. We're introduced to function overloading, or what we call method overloading. So with the method overloading, we are able to come up with the same functionality using different implementation. For example, if we want to implement a functionality of adding two numbers, and these numbers would be integers, maybe would be double, and we'll come up with two versions. We'll come up with one method that adds integers, so it will add maybe a and b, but these will be integers. And we'll have another method that accepts parameters. Its parameters accepts the arguments as double, and would add them. So what will make the two methods different would be only the parameters, that the one has got maybe integer parameters and the other one has got float or double parameters. But the two methods have got the same name, maybe sum or add. So using that, we are achieving some polymorphism in Java. So that was good, but now consider if we also have the same functionality, if it's adding functionality. If we want to add, for example, the strings, adding strings, we'll use the same plus, and we'll use maybe the same function adding, and this method would need a parameter of string and a parameter of string. So we end up having three versions, three methods doing similar things on different data or different data types. And we'll even come up with more functions depending on what we are adding up. And now consider if we have it, for example, two objects, not numbers, not strings, but any other two objects, and we want to implement the adding of two objects. If we have object A, object B, we want to add them, and these two objects are of the same type, we'll end up coming up with another method of the same name, maybe called add, but this one will be accepting two objects that should be added together. What we are trying to mean here is that with overloading functions, of course, these overloaded functions were able to achieve similar or the same functionality using different implementation, would achieve polymorphism, but this would result into coming up with a little bit of more code, and would make the maintenance of our code a little bit difficult. But there should be a better way. So Java introduced a better way of doing that. But before maybe we look at that better way, we should also take note that in the past, before the better way was introduced in Java, from Java 5 of course, in the past, they would also come up with a more generic function. instead of course coming up with a function that should add two numbers, integers together, doubles together, etc., they would just implement a function that can do almost any type of adding or adding of any type of objects. So they would use object class. If you remember, any class, every class in the Java program is a subclass of object class. So any class is a type of object class. So using that, they would come up with a program that would have the parameters as object or parameters of data type object, and this would do any kind of addition. But there was something that was supposed to be done, because operations would differ from object to object. There was a need of casting before you add the numbers. For example, there was a need of casting them to integer, then you would add them, or casting them maybe to double and you would add them. So it was still a little bit of work on the side of the user. But from Java 5, a better feature was introduced, and we call it generic feature. So with these generics, we are able to come up with generic methods as well as generic classes and interfaces. So we can create a generic thing. We can come up with something general. We can program in general, but that would work on different data types, for example. So here, Java generic methods and generic classes enable programmers to specify with a single method declaration a set of related methods, or with a single class declaration a set of related types. So this is what we are to achieve. Instead of coming up with different maybe classes that are actually doing something similar, we would come up with a single class, because maybe they are doing similar things and the only difference is the data type. We will come up with a single class that should do exactly the same. So here we are taking you through from the point of overloading functions. We are saying we are coming from the time when we could have overloading function. So here is an example where we are having an overloading function just to display elements of an array, and we are using array of data type integer. And using this loop, we are able to display all elements of the array. So we could overload this. If we want to have another variable, another method that should do exactly the same thing but on the string, then we need to have another method with the same name, and that will accept a string, and we can display all the elements of this string array. And if we have a double, we'll also have another method that should do exactly the same, and that will have the same name. So this is the overloaded method. But now, what happens with the maybe method, generic method, or generics in general? We are going to see that. But keep this in mind, that this is how we have been doing to come up with the same implementation but on different data types. Okay, so generics, this is parameterized type. So when we are talking about generics, we are talking of parameterized types. They enable you to create classes, or maybe interfaces, or methods in which the type of data upon which they operate is specified as a parameter. So we are going to have a general one. By just looking at the function, you cannot tell whether that function is working on the integers or strings or what. We don't specify that. But when we want to use it, then we specify what type of data we want to send to that. And by specifying, then that those data types that we have specified will replace the placeholders that were specified in our classes or in our methods, as we are going to see. So it is possible to create a single class, for example, that automatically works with different data types. We're going to see some examples. And previously, as I said, they would use the object. But there was a problem if we would use object to achieve the same thing, or to come up with a small general maybe class. The problem that we had, is on type safety. It was lacking on type safety. We are going to see probably with an example on how generics actually address the issue of type safety, and maybe how that was a challenge in the pre-generic era. With generics at compilation level time, the compilers ensures that the type safety of your code and this prevents any runtime error that may occur. So we are able to prevent them at compilation level. When we are compiling our code, it makes sure that whatever codes we have made are compatible and that they would not result into errors at the running time. We're going to see with examples as we go. Okay, so generics also came in with another benefit. Apart from the benefit of making or achieving a type safety, there was also another benefit where it would streamline the process of creating generalized classes. As we saw, we would come up with streamlined classes, methods, and interface, probably maybe using object class, and this would involve some casting, or would come up with overloaded functions to come up with something that is more general or that can encompass so many data types. But with generics, as we are going to see, it solves this problem. You can come up with now a very small code that is able to do anything. You are coding in not in specifics but in general. So this is so by removing explicit casting if you are using object. If you are implementing a class using object, as I said before, this would require you to cast to change it into a specific data type if you want to do some operation on that data. So that was removed. Okay, so what is a generic method? In our next video, we are going to look at a generic method and how we actually implement a generic method and some examples that we can have on generic method. So see you in the next video.